Hey guys, Paul Inventor 3 here. Trying to control the output voltage. Okay, you could see some of the other LEDs, if you look right at them, are lit. Okay, now, let's see, I'm putting out right now, right now I've got 154 volts across 90 LEDs. Now, just yesterday, I had these much brighter, and I had 184 LEDs. Usually have my output from the end of here going to my bridge rectifier, and then my meter over here, and I could check the output, and it's always 165, 170 volts. Uh, I was wondering if I remember, I think I told you guys that I was working on a part of my system that I can't show you for a while, and I said it wasn't affecting the output, which I was hoping it would, and it didn't, but I think it did in effect, because normally I would only be able to do 50 LEDs here, otherwise they start getting too much current on the last one that burns out. If somebody could explain that to me, that would be great. I don't know if it's thermal runaway. Why is it that when you put a lot of LEDs in series, it's always the last one or the first one that has the most current, or that will be the most brightest? Right now I know it's due to my meter. When I take my meter off, all these will get brighter, and I'll show you that. Like I said, though, the other day I had 184 volts. And you can see today is Friday. This was yesterday. New record, 100 LEDs in series. One coil only, too. And now I'm up at a much higher frequency, too. I had 185 volts across 90 of them. Grounding wire completely removed. I'll explain that. Alright, so let's see, let's disconnect this. Right now, we're putting out 2.286 megahertz at 16 volts. We know our frequency generator can put out only a maximum of 100 milliamps, so that's 1.6 watts. Okay, so now let's remove this meter and move the other end here. Alright, now I'm gonna have to retune them real quick. Hold on. Let's see here. They're not all lit. We're 2.0. Ah. 2.3 megahertz. Let's see. Let me keep going up. Let's see if I can find. There we go. There's another. There we go. There's another frequency now. Sometimes I get two resonant frequencies. That's 2.6 megahertz now. Yeah, some of them are lit up now a little better. You got to be looking right at them. Same old story. These LEDs that I'm using here. Anyhow, yeah, the other day I had them lit up real bright, and of course it's like Murphy's Law. Now that I try to get it set up and record, it's not going to work. Anyhow, so you could ignore these. I'm going to be connecting these. I'm going to be trying for a new record. I'm thinking my output might be limited because of my bridge rectifier. Now see, here's the thing here, guys. If I add, let's see, here's a length, 2 short alligator clips. Whoops. Alright, if I connect this to the last one here. Oh. Okay, hang on. I might have to retune. Alright. Of course, it's not working now. Oh, there they go. There they go. Okay. Definitely brighter than they were just a minute ago. Okay, and there's no, I don't have my probes on there now, so, but they were much brighter the other day though. I had them all really nice and bright. See, I just added this on here. It makes a difference. I refer to this as my grounding wire because depending on how I hook this whole system up, it could be a grounding wire or it could become like an antenna wire, and the length of this is very important. Alright, the other thing, yeah, I'm wondering if these diodes are limiting my output. I know if I try this type of, store-bought full wave bridge rectifiers, I get a lot, well, I don't have this hooked up now, but I get a lot less voltage from my multimeter. Now normally I would connect this wire right here to there. There's been circumstances when I've had this going to earth ground, but it's not needed in my circumstance here. Yeah, so if I connect these, I get a lot less voltage. So I'm wondering, I really think that this is limiting my output. I'm gonna go back to Don Smith stuff, and I think he's got a different way of transforming it AC DC, because even though this is a pulse DC, I still have AC in there, and that's why I need this rectifier. But yeah, we could do away with that anyhow. I've been also experimenting with different coils here, primary coils. As Don Smith says, the length of this will determine your frequency. These are, here's another one here. This is approximately 50 feet. It's 49.2 feet, 20 megahertz wavelength. And so is this. Same gauge wire, but of course there's going to be more windings on here. Now when you use the same gauge wire, it doesn't matter what diameter core. Hey guys, this is a week later. Forgive me, I'm gonna try to edit this in here and take off where we just left off in that last little clip. It's raining outside. I was saying about this coil, as long as I have the same diameter wire, this has the same diameter as that does, and you could notice 2526 millihenries, 0.2526 millihenries. So yeah, I found this out through my own experimentation. Now these ones here have the same length wire as these do, but they're a much finer wire. Now that gives us 1.2 millihenries. Same length wire, just because we changed the diameter that affects the induction. Now so far I don't think the induction is important. More experiments will have to be done, but you can see now I'm using this coil here, same diameter wire, but now this is only half the length or wavelength, which now we're working, if you could see that. But now we're over 2 megahertz. So we've doubled our frequency output by changing our primary. So okay, I wanted to finish making that point, and I'm going to wrap this video up. I'm attempting to get 100 in series here, and another 100 in series. We'll see if I can. So that'll be the next video, most likely. Alright, see you guys soon.